I want to do one more example, but this time I want to start with the graph and then go towards the motion diagram. Okay, and if we do that, what I want you to do here for a moment here is that what does this graph actually mean? So when you're looking at this graph, what are you seeing here? And I think one of the things that I want to do here is that I think I just want to focus on the graph and actually make it nice and big so that we could interpret this thing here. So let me paste this guy in, and then I want to make it nice and big. So what am I seeing here? Well, the first things that we really want to look at is that we want to look at what do I know about the curve? Well, right away, what you're seeing here is that there are 3 intervals. There's clearly an interval where I have a positive slope. Positive slope means that I must be what? So if I look here, this is a positive slope. So this implies that I'm going which direction? I'm going in the plus direction. But plus, in our case here, it's going to the right. And then what you're seeing here, that in this other situation, note that this is a negative slope. But what does negative slope mean? It means that it's moving in the negative direction, of course, but that in our situation right now, it's moving to the left. But note, if you're going to the right and then suddenly going to the left, at some point you have to stop. And you could see in this situation right here that because the slope is 0, we know that at this point here, it's at rest. In other words, the speed is 0 at that point because you have to have, you have to stop in order to change directions. So here we go. So the first thing that I'm seeing here is that my initial position is at what? 25 meters. Okay. So here I go. So that means when my clock is at T, I'm going to move it down because I'm going to run out of space. Let me see, or let me be more careful here. At T equal to 0, I have an initial position of 25 meters. And the question is, what is my slope here? Well, if I look at my slope, we could see here is that my slope for the first curve should be what? The height change over the horizontal change. And so you could see here is that slope tells me that I see a slope change of what? That's going to be 25 meters. So then I'm going to have 25 meters. And then my time interval, you could see, is 20 seconds. So of course, then I have a 5/4 meter per second slope. So that means this object is moving at what speed? 1.2 meters per second, 2.5 meters per second here. So now what I'm seeing here is that when I look at my diagram, I'm seeing that at our point t equal to 0, this guy is moving this fast, where I know that the velocity is 5.4 meters per second. Okay, it's going to keep doing that. And then something magical happens. What happens, as you could see here, is that look at this point here at 20 seconds. There's a discontinuity there. So what happens to the car then is that it does what? The very next split second, what does it do? It instantly stops. So then it comes to right here, and then it literally stops instantly. Now, is this realistic? Of course it's not realistic, right? It instantly stops. So now that it's instantly stopped, what does it do? It turns around. Now, as it turns around, you're seeing a much steeper slope here. So the question is, as it stops, how long is it here? So it stops, and then what it does here is it's at rest for how long? It's at rest for 30 minus 20 seconds. It's at rest for 10 seconds. So we just sit there. And then finally, what happens next is that you see that there's a negative slope. So when I look at this slope here, what you're seeing here is that at this time right here, at t equals to 30 seconds, the slope changes. In other words, the car goes from a speed of 0 to what speed? Well, I'm going to look at this slope here. And when I look at this slope, what you're seeing here is that this slope is, look at that, it's going to be negative. Of course it's going to be negative because I'm going from 50 down to 0. So the way I should do it here is I should do this as 0 minus 50 meters. And then my time intervals from 30 to 40. So what you're seeing here is that the slope now is minus 5 meters per second. So if I compare the speed of the first slope, that is smaller. So therefore, I should now have what? Longer velocities. It instantly speeds up. You know, it's not going to, see, if this is the origin, you can see how I'm having trouble right away here. I mean, let's kind of assume that this curve continues to move in this way. Otherwise, the spacing gets all kind of crazy here. But this slope right here, you could see, is then going to be 5 meters per second. And in this previous case, let me erase this, and I want to put a plus sign here. So this is plus 5 over 4 meters per second. And because it's going to the left, then I'm going to come in here and I'm going to put a minus sign here. So it has a speed of 5 meters per second, but it's going in the leftwards direction. And so that's how I interpret this thing with our numbers right here. And then how long does it speed up for? According to this whole interval should then be 10 seconds long. The green interval, which of course it's not scaled right, is going for 20 seconds long. And then we talked about the rest being 10 meters per second.
I have a question.
Sure.
So when you're dealing with the position versus time graphs, the slope is actually telling you whether or not you're moving forward or backwards, versus when you're dealing with the other graphs that we were looking at, the slope was telling you the velocity.
Yes.
Okay, cool. Thank you.